Okay. Yes, this is live. Okay. Hi everyone. Welcome to this last stream of Istio. Today we are going to do the resiliency and chaos testing, and it's quite hot in Mumbai today, so probably going to turn off the camera after some time because it's quite hot. Okay, so let's begin. So we will be exploring some of the features provided by Istio to increase resiliency between the services. So this is useful when you're building a distributed application, things like retries, timeouts, circuit breakers, and also fault injection. And you can also tune timeouts, and these are all given by HTO to you, right? So I'm again gonna put this link to the workshop. Academy, don't have the direct link. Let's find it. Academy.solo.io. Go here, you go to the HTO certification courses, and it's this. This should be the link that takes you to the free course. There's another one, Zero to Production, that's also free. Okay, so we're going to start with retries and go all the way to circuit breakers and fault injection. So let's begin. This should be a very quick stream, I guess, 30 minutes or so. So retries are very simple. In networking, there can be sometimes your services are not responding or they're taking longer to respond. So you want to retry. Basically, this is something that you would usually put inside your application in a normal microservice. So your application would have like a exponential backoff or something like that to retry X amount of times, and then if that doesn't, it will give you an error. So that's one algorithm, I think. I'm not sure if they use it there, but I have heard of it before there. Yeah, so by default, HTO will give you two times of retry. Like if your service fails or if your connection fails, it will retry twice to that particular service, right? So you can also what do you say, modify this thing, right? So we'll just see how to do that. So yeah, I'll just go to turn off my camera. Okay, so it removes my camera as well as audio. How do I only remove camera? Yeah, this should work. Okay. So yeah, we will first check this file, and in this file, it is shown that we have a host that is purchase history. We have this header that we use to match it, and we want to match it with the user Tom. We have the route, the destination. The host is again this purchase history, and we are routing it to a subset called V3, port number 8080. We have retries attempts as 0. Okay. So now we are disabling the retry, and there is another route destination that goes to the subset V2. Okay. So if the route matches header Tom, then you will have this route. Otherwise, it goes to the V2 and V2 route. So let's apply this virtual service. Let's just check the pods are there or not. Yeah, purchase history V1, purchase history V2, purchase history. I don't see purchase history V2. I see V2, but I don't see V3. Not sure. Okay, let's try it out. Oh, so here we are going to deploy the V3 also. And in the retry option, what is it saying? You can create a new version of the purchase history which errors 50% of the time, the 503 error code, and 4 seconds of error delay. Okay, so you will use it to simulate a bad application deployment and show how retries would prevent end users from experiencing them. Okay, so this is something that you would usually use in testing. So here we have this listen address. We have the name. So this is the fake service, and we have the response that we get. We also have an external service URL, error code, error rate, and error type is delay, and you have 4 seconds of delay. So you have zero point 0.5, I think that is 50%, and you have an error code of 503. So this all will be sent to the client basically, and we'll see how Istio helps us with this. Okay, so all right. So let's generate some load. So yeah, this will give you the load, and all right. So we see there are 503 errors. I think 3 out of 3 times should be 503, and then the rest should be normal. Let's add back the automatic retries by removing the retry items in the virtual service. So now it should be two. Okay, and now we will try to do this again. Okay, so you can see there is a delay of 4 seconds, and there's also a retry that happening. So we are not getting any 503 because 50% of the times, right? So it should be 200 always. If you check the logs, okay, once you check the logs, we'll see that we got these retries that happened like twice, once, twice. So every time there's an error, STO will retry, right? So if there was an error returned 503 at one time, we again added, like again got a retry, and that's how we saw that okay, there is no what do you say, uh, so if the application returned 503 one time, it would retry it again, and if it would add 503 again, it would retry again. So then it's a 200 because 50%, right? If I'm doing math right. So yeah, so sometimes you have to just retry once, sometimes you have to retry twice. So that's it. Oh, so this is X Envoy attempt count. So this is the amount of times it attempted, I guess, rather than the retry. But it's something similar. First request was not successful, but the automatic retry was successful. Note the error code has to be 503. Change the error code to 500. The updated version. And send some request to the purchase history from the sleep code. You will get errors 50% of the time. Okay, so it has to be 5. So HTO by default does it only for 503, right? The two times error. So only 503. Let's take a look at the traffic in the Kiali UI. Okay. So let's see Kiali UI. It's loading. Will it load today? Yes, it will load today. Okay, so go to the namespace and then we do display, traffic, mission, security, which to the last. So yeah, we can see success and error rate. So timeouts. Istio has built-in support for timeouts with client request services within the mesh. The default timeout for HTTP request in Istio is disabled, which means that there is no timeout. So by default, there is no timeout. It's unlimited. You can override the default timeout setting of a service. So, for example, in the route rule within the purchase history resource, you can add the following timeout configuration to set the timeout to allow three rate attempts. So let's see what we have in this. Okay, so we have a virtual service, purchase history. We have the same thing if it matches user header Tom, social version 3. We have these new things here, retries, temp 3, and per try timeout 3 seconds. So every retry, it will wait for 3 seconds. Global timeout is 6 seconds. Okay, so let's go ahead and test this. First, let us apply. What happened? Did we not step? Sometimes there is that validation. Okay. Okay. Now let's do the. I'll try to get request again. Okay, we can see that the request is timing out. So since we had the retry, it should have retried, right? But it doesn't retry because the retry will be done only for specific retry conditions. So you can basically specify when you want to retry, like what kind of error or something like that, or connection reset or something like that. So default retry on conditions don't include the response taking too long. So there is no default of okay, if the request is taking a long time, then I should retry. It's basically on the error port, right? 503. If that's it, if I'm getting this right. Happened it's 3 second per try timeout. So which is what happened with the 3 second per try timeout. The delay taking 4 seconds. So the delay we have set for 4 seconds, but the per try timeout is 3 seconds, so it fails. And there is a link to the conditions that Envoy can retry on. Let's see those. Uh, so yeah, you can retry on 5xx, you can retry on gateway error, reset, connect failure, Envoy rate limited, retryable 4xx. There's a lot of different things that you can do. Now we will check the retry condition to include 5xx errors. Now it was per try timeout, right? And now you can see you have this option to retry on, and it can retry on a lot of things. Let's see, we apply this. We applied it, and now let's let it load. So now there is no errors due to the retries being done for delayed responses. So since we have configured this, that retries again on these errors also. Circuit breaking. So let's see circuit breaking. Circuit breaking is an important pattern for creating resilient microservice applications. Circuit breaking allows you to limit the impact of failures and network delays, which are often outside of your control. When making requests to dependent services, prior to having a service mesh, you had to add logic directly within your code for language specific library to handle situations when the calling service fails to provide desirable result. Istio allows you to apply circuit breaking configurations within a destination rule resource, eliminating the need to modify your service code. Okay, so I am also not exactly sure what circuit breaking does, but so it allows you to limit the impact of failures and network delays. Let's take a look at the example here. So what it says, it defines a connection pool configuration to indicate the maximum number of TCP connections, show the maximum number of HTTP requests per connections, and set the outlier detection to be 3 minutes after an error. When any client access a purchase history TR curve, the circuit breaker behavior rules will be followed. Okay, let's see what that is. All right, let's go through this. So we have the usual, the host, the subset, label version v1, v2, v3, traffic policy. In the traffic policy, we have connection pool, right? There's a TCP max connections, there's HTTP one max pending request one, max request for connection one. Okay. We have outlier detection and it's consecutive 500 errors are one. The interval is one. There's a base ejection time of 5 seconds and there's a max ejection percent of 100. All right. So this is okay. Probably they have explained it down. So I'll just apply this. Let's see what happens with it. Okay. Okay. So basically that this what it does is if there are what so if any one or so time you see a 500 error on the service, HTO purchase history backend will just remove it. Like it will just remove it from the routing, right? So you won't able to send more traffic to it, right? So and then probably the DR. But did we apply the DR? So we applied the DR apply labs DR v3 CP. This is a bit confusing. Okay, let's see. So every time we remove we get a 500 error, it will just remove the service, right? And there's a base ejection time of 5 seconds. So and there's an interval of 1 second. So let's just see what we have out here. Detection. HTML. Right. So before host is ejected from connection. So this is a consecutive of this. The interval must be between injection sweep analysis must be greater than 1 millisecond. Default is 10 seconds. Okay. Base ejection. The host will limit. So, okay. So basically, what happens here is this host is ejected for 5 seconds, right? And the interval is 1 second to check, but meaning between the ejection sweep analysis, the interval is 1 second. And consecutive is one. So for 1 time we receive it, it will remove for 5 seconds, right? And the maximum that we remove is currently 100. So everything gets removed. So that's how we get this, you know. So you notice this no healthy. So we have removed we basically removed your upstream, right? For 5 seconds. So this thing that happens here is 5 seconds. It gets added back, right? We get a normal error, a normal response, and again we get this 500 response probably. So it then again removes it for 5 seconds. That's cool. So can you apply it in the Istio system namespace? That we'll see ahead in the workshop. The destination rule applies to requests from any client to function. We can also we can also define this client scope, but this is in the other Istio. All right, let's do the last typing section. That's fault injection. So it can be difficult to configure service timeouts and circuit breakers properly. Istio makes it easier to get these settings correct by enabling you to inject faults without modifying your code. With Istio, you can perform chaos testing of your application easily by adding an HTTP delay fault into the web API only for the user aim so that the injected fault doesn't affect any other use. So probably this is like a dev test thing where only the user AMI will get affected. So let's see what it is. So we have here this thing fault delay, fixed delay 15-second percentage value 100. All right. 30-second fault delay. But this is only 15 years. Let's try it. We have a fixed delay of 15 seconds. Let's okay. So if we have the user AB, then we have a fixed delay of 15 seconds. I think this is a typo here. So Istio will automatically inject this delay of 15 seconds here. But I think it should be 15 years. I'll check this. I think it's 15 second here. Right. So this is fault injection. So you can basically add delays to your application, you know, on your own. You don't have to add the delay within the code of the app. You can just do it. You can just do it within HTO's virtual service. So yeah, that's it. And this does it with the HTO proxy container. So that's it for these three session. I'd say I probably try to do HTO in just like a terminal. So we'll just do some. I'd say something which is normal HTO. We'll just take applications, add it to the mesh, try to do stuff with it like how we did here. But it won't be like an instruct lab, so everything is normally working. So that will probably help me also solidify knowledge because there the errors will be different. I won't have all these pre-made things, so it's just a way to learn ahead. But let's see when I get time to do that. But this is it for these three sessions. This should help. I mean, this was mostly for me to go through these labs, with proper like time constraints. So this session is quite short. It's like just 30 minutes, I guess. Yeah, almost 30 minutes. So for the next sessions, I will try to also look into something called as Harvester. And I'm going to try to install on my home lab. And to do that, I'm trying to figure out how to record it because since it's on a different machine, I won't have access to this screen. So yeah, let's see. Anyways, that's it. Thank you, everyone. Thank you for attending. It's just me, I guess. So thanks to me. Yep. Bye bye.